So today we're going to solve these inequalities that we've been working on, but we're going to show a check. So just like we showed checks with our equations, we're going to show checks for these inequalities. It's going to be a little more on these because we need to do more than just check the answer. We need to also check and make sure that our arrow is pointing the right way or that inequality is correct. So is it less than or is it greater than? We have to check that as well. So there's actually two checks for these. So we're just going to run through two of them. Starting with number 3. First of all, we're going to solve it. So first thing we're going to do is we're trying to isolate this variable. So we want it to just be an m on this side of the inequality. So the 5 and the -9 need to go. We always save the one that's attached to the letter for last. So we're going after the -9. To eliminate it, we got to get it to 0. So we're adding 9 to both sides here. So it goes away. On the left side now, -12 plus 9 gives me -3. Bring down the inequality. And then on the right side, since this is gone, the only thing that's left is m over 5. So now that's my new inequality. One step to go. If m is going to be completely isolated, the 5 needs to go. It says divide by 5, so I need to reverse it to get rid of it. So I'm going to times by 5 on both sides. Now, I'm multiplying 5 times -3, and a lot of students think, well, I'm multiplying by a negative, so I need to flip this. But that would be incorrect. I'm not going to flip this inequality because the number that I'm multiplying both sides by is 5, and that's positive. So the only number that matters is the number that you're actually multiplying on both sides. So the 5 in this case. Since it's positive, I'm not going to flip this inequality. It's going to stay exactly the same direction. 5 times -3 is -15. These 5s cancel, leaving me just an m. So notice I got a negative answer. A lot of students also think, oh, I got a negative answer. I need to flip this. That's not true. Okay? It doesn't matter what the answer is. It doesn't matter what any number in the problem is, whether it's positive or negative. The only number that matters is the number that you're doing on both sides, multiplying or dividing. If it's positive, leave it alone. If it's negative, that's when we flip this. Now, this answer is correct, but we always want to write these in terms of our variable, meaning that the variable comes first. So I'm going to rewrite this with the m on the left and the -15 on the right. Now, if I flip the letters, the inequality needs to stay equivalent. So it was telling me that -15 was greater. It was open towards the -15. So when I rewrite this, I want it to say the same thing, just with the letter on the left. So if it's open towards the -15, it still needs to be open towards the -15. These two things say the exact same thing. Okay, they're just rewritten differently, but they say the same thing. This is the answer we're looking for, though. We want the variable on the left side. So I've got my answer. Let's put it on a graph. Don't need to do anything fancy with the graph. We're going to put a open circle at -15. It's open because there's no equal sign underneath of this. Okay, so we're going to leave it open. -15 is not a possible answer. The possible answers for m is everything less than -15. So not -15, just everything less than it. So all the numbers less than -15 on a number line are to the left. So we're going to shade all the way left, put an arrow showing that it goes on forever in that direction. You don't have to put any numbers here. We don't have to make any tick marks. You can just leave it like this. We know everything less than 15 is to the left. Okay, so that's basically what we covered on Friday. So now we need to show checks. So the first check is to see, is -15 the correct number? Is that where this line should start? So check number 1 is going to look just like what we did with equations. So this should seem familiar. We're going to rewrite the original, except we're not going to put the greater than sign. We're actually going to put equals. We just want to see, does -15 come out to the right answer for the equals part? So rewriting the original, -12, instead of the greater, I'm going to put equals. And then I rewrite this whole side, but instead of m, I put my answer, just like I did in the last unit. So -9 plus -15 over 5. Check is going to work exactly the same as the last unit. So just solve out that right side. -12 doesn't change, one step at a time. So I leave the -9 alone. Divide. That's -3. And now if I add -9 and -3, I get -12 on both sides. -12 equals -12. That's a true statement. So check number 1 is good. So what that tells me is that the -15 is correct. What it does not tell me is, do I have this arrow going in the right direction? Because I could have got negative 15 as the right answer, but I could have got greater than and put it this way. And my answer is wrong, and this check does not show me that that's wrong. It only tells me that the negative 15 is the correct starting point. So how do I check if my arrow is going the right way? That's going to be check number 2. So check number 2, what we want to do is we want to test a number that we think is in the solution set. So the solution set is all of these numbers less than negative 15. We want to test one of them and see if they work. If we test one and it works, we know our answer is right. Okay, if this is the right answer and we tested a number up here, then it should not work, because these numbers should not be part of our answer. So we're not going to worry about the ones that are incorrect. We're going to worry about the ones we think are right. So we get to pick any number we want that is less than negative 15. So we can't use negative 15. We're choosing something from the solution set. Now, we're going to rewrite this. We actually are going to use the inequality. So negative 12 greater than negative 9 plus. Now I'm going to pick a number and I'm going to put it over 5. So I have to replace m. It's m over 5. I need to replace it. Again, we're not using negative 15. Negative 15 should not work because it's not included. All the answers are less than negative 15. So if I put negative 15 in here, it shouldn't work. So I need to pick a number less than negative 15. There's an infinite number of choices here. Now what you want to do, since we're going to be dividing by 5, is pick a number that is divisible by 5, so we get nice numbers. If you just choose a random number, like let's say negative 21, and you try and divide it by 5, you get a decimal. Now that's okay, but I'd rather not have decimals. So pick a number that you can divide by 5, like 10, 15, 20, 25, 30. Now it does need to be less than negative 15. So I'm just going to pick negative 100. Because that is less than negative 15. But you can choose any number you want. Negative 20, negative 25, negative 30. Those are all less than negative 15. And they're going to give me a nice number when I divide by 5. So let's see what happens here. Nothing happens on the left. I'm going to leave the negative 9 alone. And I'm going to divide. So negative 100 divided by 5 is negative 20. If I finish off this side, I'm not going to get the same number on both sides, and I'm not trying to because this isn't an equals sign. Over here, I needed the same number on both sides because it was supposed to be equal. Over here, they're not going to be equal. I need negative 12 to be bigger than this number. So let's see what this number is. If I add negative 9 and negative 20, I get negative 29. Negative 12 stays. Now I need to actually answer this question. Is this correct? Negative 12, is it greater than negative 29? Think about a number line. The farther to the right on that number line, the bigger it is. Negative 12 would be over here, and negative 29 is way over here. Is negative 29 greater, I'm sorry, negative 12. Is negative 12 greater than negative 29? Yes, it is. And so I know my check is correct. Now let's say this didn't work out. The first one worked, but this one didn't. That means my arrow is going in the wrong direction. So really this should have gone the other way if this did not work. So this second check tells me if my arrow is going the right direction. So let's try another one and see if we can handle it. So first things first, solve, get an answer. So here's my letter, my variable. I need to isolate it. So that's the only thing I want left on the right side is the letter A. So the 8's got to go, the 10's got to go. Okay, we're going to save 8 for last because it's attached to the variable. So start with a negative 10. How do I get rid of a negative 10? I add 10. Get it to 0. So what happens? Well, on the left side, negative 10 plus 10 is 0. Bring down your inequality. These cancel. And when this comes down, you need to remember that this minus comes with the 8. So it's a negative 8a. So first of all, it's okay to get 0. Don't think you did something wrong. And don't forget to bring down your minus as a negative. Now to get a completely by itself, I need to get rid of this negative 8. It is being multiplied by a. So that means I want to divide by the negative 8 to get rid of it. Now as soon as you write this, you need to have that little bell going off in your head. I'm dividing by a negative on both sides. When I multiply or divide by a negative on both sides, my inequality flips. So this needs to go the other direction. I like to do that right away. before I even worry about the numbers and the math, as soon as I'm dividing by a negative on both sides or multiplying by a negative on both sides, I'm going to flip it. So these 8s are going to cancel. A is now isolated, which is good. That's what I wanted. And then over here, 0 divided by anything is 0. Notice that I left the A on the right side, just like I left the M on the right side up here. You can't just throw it on the other side because that's where we like it. Save that for later, otherwise you're going to get that wrong. So leave the A here, we divide and get 0. Now I do need to rewrite this because I do want A on the left side. So I have A on the left, 0 on the right. If I flip the letter and the number, I need to flip the inequality to keep this true. It's open towards the A. So for these two to say the same thing, it still needs to be open towards the A. This is the answer that I like. A is greater than 0. To put that on a graph, you're going to just put a dot at 0. Now, this has an equal sign. So 0 is a possible answer. So I need to fill it in, label this 0. And my answer says A is greater than 0. Greater than 0. So all the numbers greater than 0 are going to go to the right on the graph. All right, let's check our answer. So check number 1, we want to check and see, is 0 the correct number? So I rewrite the original with an equal sign. And then instead of A, I put my answer of 0. Now it said 8 times A, so I write 8 times 0. Then we're going to run our check. So one step at a time. First thing I'm going to do is I'm going to multiply 8 times 0, which is 0. Notice I didn't do anything with everything else. Everything stayed except 8 times 0 is 0. Now you just finish it off. Negative 10 minus 0 is negative 10. Both sides come out equal, so my check is good. Which means 0 is the right number. But that doesn't mean I put my arrow in the right direction. So now I need to check and make sure that it really should be greater than, like I have it, and not less than. So check number 2. So now I get to choose any number in my solution set. Okay, so I can choose any number up here, any number greater than 0. You could choose 10, you could choose 15, you could choose 100. When I check your homework, all of your check number 2s should not necessarily match mine. Otherwise, it's a little fishy. Pretty obvious that you're copying. Okay, sometimes they're going to match because you're going to choose the same easy number. But you can choose any number greater than 0. The chance that you're always going to choose the same one as me is not that likely. But let's choose a number that's easy to use. So a number greater than 0, that when I multiply is easy to use, I'm going to use 1. 1 is greater than 0, super easy to multiply by. So when I do check number 2, I don't put equals, I actually put the inequality, so greater than. Just rewriting the original again. And now instead of 8 times A, I'm going to pick a number up here. You could pick 10, 100, whatever you want. I'm going to use 1. Because multiplying by 1 is super easy. If you can use 1, you can use 0. Use them. Okay, one step at a time on my check. Negative 10 stays. 8 times 1 is 8. Do the math. Negative 10 minus 8 is negative 18. And now my answer says negative 10 is greater than or equal to negative 18. Before you just put a check, you need to think about it and make sure that's actually true. Is negative 10 greater than negative 18? Think about a number line. Which one would be farther to the right? Negative 10 would be, it is true. Negative 10 is greater than negative 18. This is good. Now let's say this was flipped the other way and this was untrue. It said negative 10 is less than negative 18. That means your check did not work, which means my arrow should have been going the other way, which is what's going to happen if you forget to flip this. So if you run through this whole problem, even if you forget to flip this, you're still going to get a 0. So check 1 is going to work. But if you forget to flip this, then your arrow is going to be pointing the wrong direction, and check number 2 should fail. Okay, this should not be true. It would say negative 10 is less than negative 18 or something like that. So if this check number 2 fails, it means that your arrow is going in the wrong direction, which probably means that you forgot to flip your inequality somewhere. So when check 2 fails, you need to go back and look. Did I forget to flip my inequality, or did I flip it when I didn't need to? Okay, so check number 2 tells you if your arrow is going in the right direction. There's 3 problems on the back of this for you to try. Give those a shot. When you think you've got them, let me know, and I'll get you your homework.